My name is Ashish Anil Kokati. We are taking the topic of DC motor dynamics modeling position control with my group members Shubham Savansarkar, Sherry Pakle, and Sahil Revgade, and which is guided by Dr. GVG Kumar sir. Let's go with the topic. The DC motors are widely used in various engineering applications due to their simplicity, reliability, and easy to control. From industrial automation and robotics to consumer electronics and electrical vehicles, motors play a crucial role in converting electrical energy into mechanical motion. However, the many application it is not enough to simplify rotate a motor. Precise control over its position, speed, and acceleration is essential. To achieve this control of level of control, it is necessary to develop mathematical model that accurately represent the motor dynamic behavior. This model forms the foundation for the designing control settings, such as PID controllers, that ensure the motor reaches the desired position quickly, uh, quickly, accurately with the excessive overshoot and instability. The project focuses on modeling of DC motor dynamics and the implementations of the position control system, highlighting the importance of system analysis, control design, and simulation in achieving optimal motor performance. The overview of the presentation is that the simulation model, the electrical and mechanical dynamics of the DC motor, the PID controllers implemented to control the motor position. The MATLAB Simulink is used for the system modeling and performance evaluation. The response is analyzed in terms in the rise time, settling time, and steady state error. The study highlights the impact of controller turning system behavior. So, thank you so much.
Is electrical and mechanical dynamics of DC motor. We MATLAB we simulate this model in MATLAB simulating software we use for system modeling and performance evaluation. The response is analyzed in terms of rise time, setting time, and steady state error. The study highlights the impact of controller turning on system behavior. Methodology in five types: mathematical modeling, simulating implementation, optimization, control design, and performance analysis. I explain the how output waveform generated by our simulation. So it depends on various parameters like graph components, transient response, steady state behavior, effect of control strategy, impact of load disturbance, theoretical comparison, and we generate this graph or output waveform in the terms of tabular distribution. That is depends on various parameters like rise time, overshoot, settling time, steady state error, oscillations, and load disturbance. When we observation in the graph, the rise time is slowly, overshoot is so high, settling time is too long, steady state error is exist, oscillation is too much, and load disturbance is system drifted. And ideal condition, ideal state, rise time is increased, uh, rise time is increased, then that means KP is increased, then KP is reduced and KD is increased for overshoot. Then KP and KD is same condition, and where damping increase in oscillations. So these are the brief information or brief detailation about simulation output graph. So thank you. Uh, Good afternoon. In this code, we simulate the DC motor dynamics and control for modeling. In this code, the open system for real system position controller, we plot the graph of two parameters, time and position response. This code includes that legend input functions real system and simulation. After running this simulation, we successfully get the uh, graph for time and position response for DC motor. We run this code. So we get the this graph in x-axis we get the time, and with respect to in y-axis we get the position response in radians. And the green line is show that the simulation is occurs. After that, we develop a second code. In that code, we get after that run the code, we get the block diagram directly. So in this code, we generate the figure of block diagram. In x-axis, we get the time, and in y-axis, we get the simulation response in radians, and legend commands in for input reference and control output. After running this code, we successfully get the block diagram. So in this block diagram, we add the two gain blocks. We put value for one gain block is 1. Apply OK. Then for second gain block, we consider the value for gain is 1.5, and after add the additional value for the gains is numerator coefficient 1 and denominator coefficient 1 and 1.5. So we apply here, okay, and after that we run the code. In this we get the output for the DC motor modeling and control. So we directly go for the output graph. Here we get the graph, output graph. So this blue line is the integrator value after running the code, and this is the step function graph in blue color line. So these are the descriptive explanation of our block diagram for DC motor controlling and modeling, position controlling and modeling. Thank you.
DC motor dynamics modeling and position control. I will explain the application of DC motor dynamics modeling and position control. First one is industry level application. In that, industrial robotics applications are DC motors control robotic arm in industries like automotive, example Tesla, BMW, and electronics, example PCB assembly. Second one is DC motor control techniques. In that, PID control will become ensure precise positioning of the robotic arm. Second one application is the CNC machines. In that, computer numerical control applications will be DC motor drives, drive linear actuators that control the cutting tools in milling, driving, and lathe machine. Used in a high precision aerospace part and medical impacts. Then third one is application is medical robotics. In that, surgical robots and pro, pros, prosthetics is the application of DC motor. In that, DC motor are used in a robotic surgical system for ultra precise movements, like the Da Vinci surgical system. Uh, Fourth one is a 3D printer. In that, DC motor control the print head and extruder positioning in a 3D printer. Second one is a use in a rapid prototyping medical implants and construction. That's all about my topic applications of DC motor. Thank you so much.
My name is Sarkar Shubham. My name is Somasarka Shivam. The talking about its disadvantages. So, first point is sensitivity to parameters variations require proper unit for the optimal performance. Computationally intuitive for real-time system overshoot and oscillations may occur if not done correctly. Hardware implementations, but introduce optimal complexities. So now the topic applications. So it is used in robotics for the purpose of precise operations of robotics arm and also the use in CNG machines for the accurate tool positioning and in also electrical vehicles also used for the purpose of motor speed and position control in the industrial automations highly used for the conveyor belt managements and also in medical sectors used for the maintain motions controls and storage devices. Now its conclusions. The conclusions. This is simulations creates on MATLAB softwares. MATLAB softwares is very high amount of used in electrical sectors. MATLAB simulation of DC motor dynamics and position control provides power tools and analyzing motor behaviors. Distribution effective controls strategies by the modeling motor electricals and mechanical dynamics using differential equations. We can simulate as a response under various input conditions. Implementing controllers like PID enhance positions accuracy and stability. Such simulations aids of optimizing motor performance before real world implementations, making them essentials for automations and robotics. For Thank you.